This video is about the subject of measurements and instrumentation. The topic is analog instruments. The content of the topic analog instruments is introduction. So what are the essential talks needed for an analog instrument, for indicating instruments and moving ion instruments? In the introduction, normally the analog meters we are using ammeters and voltmeters, and these are operating on the principle of um, moving ion and moving coil. So this action of all the meters, ammeters and voltmeters, except the electrostatic type of instruments, usually the electrostatic instrument is used for only measuring the voltage, and these are depends upon the uh, deflecting torque produced by an electric circuit. So ammeter deflection torque is produced by the measurement. The quantity is called current. Similarly, voltmeter deflection torque is produced by the current, which is proportional to the measurement of the voltage. So in the ammeter, the current is directly taken, and the voltmeter, what is the equivalent current will be taken from the voltage. All the analog instruments, especially voltmeter and ammeters, are measuring devices of current. So what are the essential tasks in indicating instruments? Usually the analog instruments are having some essential tasks are needed. Number one is deflecting torque. So the deflecting torque for all the analog instruments, and it is measuring the deflecting torque or the force, and controlling torque or the force, and damping torque or the force. These three are the essential tasks needed for analog instruments or indicating instruments. So the value of deflecting torque must be depends on the electrical signal. It is equivalent to electrical current or the voltage, and it also causes the instrument movement to rotate from the zero position. Then what is the controlling torque? The first torque is needed is deflecting torque, and the second torque is needed controlling torque. So this controlling torque must be in the opposite sense of the deflecting torque, and it should be equal. The movement take up on the equilibrium or definite position when the deflecting or the controlling torque are equal in magnitude. If you see, the deflecting torque will be controlled by the controlling torque, and it will be in a static position of at any number. Here the controlling torque can be considered by spiral springs or gravity usually provides the controlling torque, and it should be equal and opposite force that of the deflecting torque. So to bring the pointer back in its initial position or the zero position when current or voltage is removed. So this controlling torque is it is very essential, and it should be equivalent to the deflecting torque. It will keep the pointer in constant position when the supply is connected, and if the supply or the quantity is removed, it will come back to the original position. The controlling torque is needed. So these are the types of controlling devices. Number one is spring. So here we are using spring on the pointer. This is spiral spring and another one spiral spring. So two springs are connected to give the controlling torque to the instrument. So the spiral has spring is attached to the spindle of the moving system, and this spring provides the controlling torque, and it will give the preferred and space requirement is less. It requires very less in space. And what are the properties of spring? It should be non-magnetic material, and it have low specific resistance and low resistance temperature coefficient, and it should not be affected by any mechanical fatigue, preferably phosphorus bronze or beryllium copper is used. Another one controlling task is given by the gravity control method. So here the gravity control is used. So this is a gravity control. It will be perpendicularly used. Once the pointer will go moving in position from starting position to the end position, this gravity will help the pointer to deflect and as well as come to the original position. A small weight is attached to the spindle of the moving system, and due to the graviton pull and the control torque is produced and provided whenever the pointer tends to move away from its initial position. And this is usually given in terms of T suffix D, and it is directly proportional to the current, and it is controlling torque is T and suffix C, and it is directly proportional to the deflecting angle. So always the deflecting torque and the controlling torque should be equal. So the sign of deflection is directly proportional to the current, hence the scale is non-linear and craft scale. Another one essential torque is damping torque. So it is required to act in the direction opposite to the movement of the moving system. So this brings the moving system to rest at the reflecting position reasonably quickly and without any oscillation or very small oscillation. It should be pointed out that any damping force shall not be influence the steady state deflection produced by the given deflecting force of the torque. So the damping force is increase the angular velocity of the moving system, and this effect is greatest when the rotation is rapid and zero when the system's rotation is zero. So we have a different types of damping torque is used in the analog instruments. So first one is air friction damping. So it will be provided the air spindle is connected in the complete one chamber. The piston is attached to the spindle and to the moving system is positioned to move inside the air chamber. So when the spindle moves due to the deflecting torque, the piston moves inside the air chamber. Suction and compression actions on the air inside the air chamber produces necessary damping torque. So this air chamber and piston are made up of aluminium used in hard wire and moving iron instruments. Another one damping force provided by fluid friction. Moving vanes attached to the lower end of the spindle and dipped in oil. So greater the viscosity of the oil, greater is the opposition of the motion of the vanes. Here we are using this in instruments in panel boards, and what is the disadvantages? It cannot be used for portable instruments, and we cannot carry out in some other places because it is filled with fluid. So whatever it is fixed in some panels, there we are using this fluid friction damping, and it cannot be used for portable, and the instruments are always kept in vertical position only due to creeping of oil. Another one important damping force provided by the magnetic material, that is called eddy current damping. So this is usually used in, we may see in energy meter, electromagnetic damping is provided in the disc. The damping torque is produced based on the concept of eddy current flowing in the closed path in which EMF is induced. So with the constant field strain, damping torque produced by eddy current is proportional to the velocity of the conductor. So most efficient type of damping is this type, and used for hard wire, moving coil and induction type instruments we are using this electromagnetic damping. So the movement of coil in the magnetic field produces current in the coil, which interacts with the magnetic field to produce a tap. So this tap is opposing the movement of the coil and slows the response. And moving ion instruments. Here the moving ion instrument, it is used to measure both AC quantity and DC quantity, and moving ion instrument is categorized into repulsion type and attraction type. This movable system consists of one or more piece of specifically shaped iron, soft ions, and which are pivoted as to be act upon the magnetic field produced by the current in coil. This is the attraction type of moving ion instruments. So there are two vanes are provided. So due to attraction, both coils will be both ions will be connected with the supply. What is the quantity of way to measure? The soft iron piece gets magnetized when it is brought into magnetic field. The same phenomena happens when the soft iron piece is brought near either of the ends of the coil carrying current. So the iron piece is attracted towards that position, and where the magnetic flux density is more. Where is more, and it will be attracted. So this movement of soft iron piece is used to measure the current or the voltage which provides the magnetic field. This is another one, the same picture will give the attraction type of moving ion instruments. So the deflecting torque is produced by the current or the voltage to be measured, and it is proportional to the controlling torque, square of the voltage or the current. Hence, this instrument can be used to measure both AC and DC. The scale is non-uniform. The controlling torque is provided with spring or the gravity, and damping is provided with air friction damping. So we already seen this, what are the controlling methods, controlling torque methods and damping torques. And another one type of a moving ion instrument is the repulsion type moving ion instrument. So this is the cross section, front view of cross section, and this will be angled cross section. So these two are two different pictures and two different angles. So two iron pieces kept in closed proximity. So this is one way, and another one way will be connected here, the two dots, and the square will be one way, and another will be curved. It will be fixed in the curve, and field get magnetized to the same polarity, and hence repulse force is produced. So this will be connected with a spindle and the pointer. So due to repulsion, the pointer will move. If one of the two pieces is made movable, and the repulsion force will be acting on it and move it onto the one side. So this movement is used to measure the current or the voltage which produces the magnetic field. So this is the another one picture for the moving ions instrument, repulsion type moving ion instruments. So when the current is to be measured and it is passed through the fixed coil and gets an own magnetic field, and which magnetizes two rods similarly to the adjacent points of the lengths of the rod will have the same magnetic polarity. Hence they repel each other, with the result of the pointer is deflected against the controlling torque. So the force of repulsion is approximately proportional to the square of the current passing through the coil. Whatever be the direction of current of the coil, of two ions are always similarly magnetized. So this is the Tark equation, and this Tark equation gives the moving ion Tark equation gives the electrical energy supplied and as energy stored on the magnetic. And what are the advantages of moving ion instrumenters? The advantages, this instrument can be used for both measuring AC quantity and DC quantity, and it is very robust owing to the simple construction of the moving parts. And it is the stationary part of an instrument is also very simple and low cost compared to PMMC instrument, and the torque weight ratio is high, so it has less friction. And the disadvantages, scale is not uniform, cramped at lower end. So series errors due to hysteresis, frequency changes, stay magnetic field, and it will increase in temperature, increase in resistance of the coil, decrease the stiffness of the springs. And what are the errors will be possible in this MI instrumenters? Hysteresis error, and this is due to the different values of flux density, and temperature error due to effect of high temperature on the temperature coefficient of the spring cause self-heating of coil can be avoided by using manganese material, and stay magnetic field due to weak magnetic field, and frequency error due to change in frequency, eddy current error, it is due to protection of eddy current in the iron parts of the instruments affect the system. So about this moving ion and what are the essential tasks completed. Thank you.